Hello and welcome. Today I am going to be going through this question with us. This is question number 20 from the 2020 May exam, paper 1H, the GCSE. Our question says, show that this expression can be written in this form. And not only that, they also say it right here where A and B are integers. Now, with a show question, you want to make sure you focus on how they want us to give the answer, what format the answer should be in, or how the answer should look like, as well as the conditions. So we have a format, we also have the conditions. A and B must be integers. What are integers? Integers are positive or negative whole numbers. No fractions, no decimals, no surds for A and B. A and B must strictly be positive or negative whole numbers. So here we go. It's a format question, so you really want to show your steps right there. Always take a glance or a look at the marks. I'm just going to start out by rewriting question. Okay, so we have the square root of 180 minus 2 root 5. The whole expression divided by a 5 root 5 minus 5. Now, remember, when we're asked to show that, what they want are the steps of how to change this expression to look like the answer format. How can we change this to that? What's coming to your mind? When we have a fraction with surds in the denominator, you want to think of rationalizing the denominator. I have a video on rationalizing the denominator. You can watch it. I go through the basics. But for today, let's work on this question together. We are going to multiply both the numerator and the denominator by the opposite of the denominator. So meaning I'm going to multiply this by a 5 root 5 plus 5. Same thing in the denominator, a 5 root 5 plus 5. The opposite is when I simply change the sign between the terms in the denominator. You see, so the opposite becomes 5 root 5 plus 5. Now I'm going to insert brackets right here to allow for multiplication or to allow for expansion. Now keep in mind when you're multiplying fractions, the numerator multiplies with the numerator, the denominator with the denominator. It's as simple as that. Let's get started. I am actually doing the laws of expansion, meaning my root 180 would multiply with the first term, and then after that it will multiply with the second term. Then I do the same thing with the negative 2 root 5. I do the same thing. All right, so getting started with those steps, I start with my root 180. So our root 180 times 5 root 5, I don't want to simplify that instantly, so I'm just going to write it as 5 root 5 multiplied by root 180. We can leave out the multiplication signs. Okay, then I move on to root 180 times 5. So that's going to be a 5 root 180. Done. We move on to our negative 2 root 5. So it's going to multiply both terms one at a time. So let's start with negative 2 root 5 times 5 root 5. That's going to give us a negative 10 times 5. So I'm just going to zero in on this one. What did we do right here? So remember, if we are multiplying and our surds have numbers multiplying with them, the numbers would multiply naturally. So the negative 2 times 5 are just whole numbers, they multiply naturally. And that's how I got the negative 10. Then after that, I did our root 5 here times the root 5. So remember, root 5 times root 5 is just a whole number, 5. Okay, then moving on for the last one. I am doing the last one. Okay, our negative 2 root 5 times 5 right there. That's going to be a negative 2 times 5, which is a negative 10, then times root 5. Once I'm done, I can move right away into the denominator and do exactly the same thing, expand. Right? We're going to do exactly the same thing and expand. So I have 5 root 5 times 5 root 5. So again, you really want to slow down here and make sure we do everything correctly. So my 5 times 5 and then my root 5 times root 5. Let's execute. 5 times 5 is 25, multiplied by root 5 times root 5 is simply a whole number 5. Okay, done with that step, we move on. 5 root 5 times 5 at the end right there. So I'm doing this step. That's going to be a positive 25 root 5. Okay. Finally, I'm doing my negative 5 with the last two terms. So executing one at a time, I have negative 5 times 5 root 5. So remember the whole numbers multiply. So I'm going to have a negative 25 and carry along our root 5. Then the last term and the last term, that's negative 5 times 5, which is a negative 25. Now that we are done with expansion, it's time to simplify. How do you simplify? You want to collect like terms in the numerator, collect like terms in the denominator, then we move on from there. Remember, it's a show question, so we have to show all our steps. Now, some of the terms in the numerator would need to be simplified. So let's talk about our root 180 here, the square root of 180. The square root of 180, if I do it on the side, can be simplified. Take any two factors of 180 and then simplify the surds from there. I'm going to use a square number and a prime number. 180 can be written as 36 times 5. Then from there, I can separate into root 36 multiplied by root 5. Then square root of 36 is a whole number 6. So that just returns a 6 root 5. Now I'm going to use that and replace every root 180 with a 6 root 5. So when I do that, what does it look like? Okay, let's go through it together. So we're going to have this 5 root 5, which we already had, now multiplying with root 180, which is being replaced by a 6 root 5. Done. We move on to the next term. I have a 5 multiplying again with a root 180, but we said root 180 is going to be replaced with a 6 root 5. And I move on to the third term. That's just ordinary multiplication. 10 times 5 is a 50. At the end also, I have 10 root 5. Root 5 cannot be simplified any further. 5 is a prime number, so that's pretty much about it. In the denominator, 25 times 5 would be 125. If you're not sure, you can do your column multiplication on this side. So 5 times 5 is a 25, so that's 5, carry 2. Then 5 times 2 is 10 plus 2, that's 12, so 125. Okay, remember this is a non-calculator paper. Okay, moving on to the second term in the denominator. Interestingly, the second and third terms are like terms, meaning we can put them together. So that's a 25 root 5 minus 25 root 5, and essentially this is going to cancel out. It's going to give us a 0. So those two terms gone. So all we have really is the 125 minus 25. We continue simplifying. Okay, I am going back to the numerator. Now I'm going to multiply the terms, or the first term, and give my answer in this, in the simplest form. So 5 would multiply with 6. So 5 times 6 is 30. Then root 5 times root 5 is a 5. So times 5. Moving on to the second term, 5 times 6 is a 30, so 30 root 5, minus 50, minus 10 root 5, done with our numerator. And in the denominator, I can actually collect those two terms. 125 minus 25 will just give me a nice 100 right there. Your steps may not be as many as mine when it comes to simplifying, but because I want to explain term by term how we are, progressing with our simplification, term by term, both in the numerator and the denominator. Okay, I'm going to rewrite this one more time, and let's take a look at how things go. We are collecting like terms. Now 30 times 5 here, this is 150. So our 150 and our 50 would subtract naturally. So 150 minus 50, that would give me a whole number 100. And similarly, my 30 root 5 and my 10 root 5 are like terms. When I collect them, that's 30 minus 10, that's a 20 root 5. All of this divided by 100 in the denominator. So right here, I am done with simplifying, right? But then I take a look at the answer format. They want the terms to be separate, 2 terms in the final answer, an a, which is a whole number, an integer, plus a root 5 over another whole number. So we are pretty much done, but our answer doesn't look like the format. So we want to make sure we give our answer in the required format. And to do that, I am going to separate the terms in the numerator and express them each one separately over the common denominator. Remember, 100 here is being shared by both terms in the numerator. Both of them are dividing by 100. So meaning I can write them separately as 100 divided by 100 plus 20 root 5 divided by 100. Now it's time to simplify even further. So in simplifying, we are going to have 100 divided by 100 would just give us a whole number 1. Plus, we move on. When it comes to simplifying with the 20 over 100, that's simplifying fractions, right? 20 over 100. So if you think about it, if I do it on the side right here, 20 over 100, I could cancel out 1 0 and 1 0 in the numerator. So all I have is now a 2 over 10. Simplify this by dividing by 2, divide by 2. That's going to give me 1 over 5. So really, 20 over 100 is 1 over 5, but don't forget the root 5. So the 1 would multiply with the root 5 in the numerator. 1 times root 5 would still be root 5. And in the denominator, remember, we now have a 5. Now, I'm just going to write out the format of the answer right next to our answer, and we can actually tell the values of A and B. They say they want the answer to look like this. A plus a root 5 over B. So we can actually match, right, that our A is the 1 and our B is a 5 right here. And this was the correct solution according to the mark scheme. Watch out for more videos with a lot of past paper questions, just explaining how to work with surds, how to answer questions on surds in the exam. Thank you.